Okay, this is the November 2017 paper 2 galvanic cell question. It says learners set up a galvanic cell and measure its EMF under standard conditions. Write down the name of component Y. This is component Y. We are measuring EMF. We measure EMF with a voltmeter or a multimeter. You could technically put an ammeter there, but because we're measuring EMF, we need a voltmeter. Now it says, is aluminium the anode or the cathode? Can you see there's aluminium and silver over here? Anytime you get one of these questions, the first thing you should do is you should open up your table of standard reduction potentials and start looking for the things you've got. And here we've got the silver, and there on the other side we have the aluminium. So these are my two reactions. Obviously my table is split, but you can see that this one has a positive value and this one has a negative value. So if you have a positive value, you know that the forward reaction will take place, and the forward reaction is reduction, or the forward reaction is favored, and the backward reaction is oxidation. Okay, so if you've got a negative value, the oxidation reaction is more likely to occur. So if you go back to the question, it says, is aluminium the anode or the cathode? When you do these questions, you should always remember oil rig, red cat. And red cat stands for reduction occurs at the cathode. So if we look at the table, the silver reaction, can you see I've cropped them out here? The silver reaction is positive. It is the forward reaction. It is a reduction reaction. The aluminium reaction is negative, which means the reverse reaction of oxidation is more likely to occur. And they want to know, is aluminium the anode or the cathode? Well, at the aluminium, the reverse reaction is taking place, which is the oxidation reaction. So reduction occurs at the cathode, oxidation occurs at the anode. So the aluminium is the anode. Now you've ringed the reactions in your table, and I've put them up over here, and you're going to use these to answer the next question. It says write down the overall or net cell reaction that takes place in the cell when it is working. So we know we're going to use the reverse reaction, okay, for the aluminium. The aluminium is going to go to the aluminium 3+, and we know that the forward reaction for the silver is going to occur. The silver plus is going to go to the silver metal. My only problem here is these electrons. The silver reaction is 1 electron. The aluminium reaction is 3 electrons. So we have to multiply this reaction by 3 to balance the electrons. So if we have a look here, what will happen on our reaction? It will be aluminium plus 3 silver ions will go to an aluminium 3+ ion plus 3 silver metal. So maybe we should rub this out and write it neatly. Let's try and write it a little bit more neatly. Remember, we are going to make the silver multiply by 3, and it's the forward reaction. So we have 3 silver ions plus some aluminium, because it is the reverse reaction, going to 3 silver metal plus 1 aluminium 3+ ion. So you have to balance the electrons. 2 marks for just writing the reaction. The silver ion plus the aluminium goes to the silver metal and the aluminium ion. The 3rd mark for balancing it. Now it says calculate the initial EMF of the cell. So then you go to your table and you find your formula for this. Remember to copy the formula 100% exactly as it is on the table. So I always use this one because it's the shortest one, more or less. Well, I just prefer this one. So it's E theta cell equals EO reduction minus EO oxidation. Okay, so which one was the reduction reaction? Which one was the forward reaction? The one that was positive. So we're writing 0,80, and then we will subtract the value of the reverse reaction, subtract minus 1,66. A minus and a minus makes a plus. put it in your calculator, you'll get out 2,46, and it is an EMF, so we measure it in volts. Remember to put your units. So that is the initial EMF. Now it says to you, consider the two half cells PQR represented in the table below. So we've got zinc and zinc 2+, chlorine and the chloride ion, and copper 2+. So the first thing you do is you go back to your little table and you start looking for all of these people on the table. Here is the chlorine reaction. Here is the copper reaction. And where is the zinc reaction? Is over here. Okay, so if you have a look, the chlorine is the most positive, then the copper, and finally the zinc is the most negative. And it's good to look at them in their relationship in the table, because we know a spontaneous reaction is most likely to occur between two things that are separated widely in the table. The further you are separated in the table, the more likely it is for a spontaneous reaction to occur. So let's go back here and have a look in the question. Okay, if you look over here, I have put these reactions over here, all of them in order from the table. So it says, different combinations of the half cells above are compared to determine the highest EMF produced under standard conditions. So basically they're using this setup over here, and they will compare these two things with each other because this is a standard 2 galvanic half cell setup. Now it says, write down the name of a suitable electrode for half cell Q. If you look at Q here, Q has got our friend chlorine, and it is a gas. You cannot complete an electrical circuit with a gas, so you need some kind of inert electrode, and so we can either choose carbon or platinum. Platinum is non-reactive, so it makes a good electrode, and it provides electrical continuity. It says, state the standard conditions under which the half cells should operate to ensure a fair comparison. We always have to have standard conditions for this because it is an equilibrium reaction, and anything that can affect the equilibrium needs to be taken into account if you want to have a fair comparison. So once again, you go back to the back of your question paper. At the back of your question paper is your data sheet over here, and you start looking for standard conditions. This standard pressure is one that you can use, okay? And then you have to just be careful about the standard temperature. This standard temperature is 0 degrees C, okay? So this is not the condition most people work in a laboratory in. We usually like to work at room temperature. So this one is not the standard temperature, but you need two things. So if you're going to use the pressure, get the pressure off the data sheet. It's 1 atmosphere pressure, and this is its value. But we will do this at not this temperature, but at 25 degrees. And so we can use this to say 273 plus 25 is going to give me 298 Kelvin, which is a good value for room temperature. But you can always get the standard pressure value off the back of the question paper. So you either write down the 1 atmosphere pressure using the correct value from the data sheet, 25 degrees C, and the other thing that affects reaction rate, things that affect reaction rate are pressure, temperature, and concentration. So the concentration for this is usually 1 mole per cubic decimeter. Okay, now it says to you, write down the name or the formula of the strongest reducing agent. Remember, the strongest reducing agent is oxidized. So if we are looking for something that is oxidized, it is always on the right-hand side of the table. But remember, the table is very helpful. If you go to the table and you look at the table, there are little arrows that say increasing, reducing ability. So if we look for the one with the increasing and reducing ability, who is furthest down here and is on the right-hand side, because the reducing agents are on the right-hand side. The one furthest down and on the right-hand side will be zinc metal, which is Zn. It's on the right-hand side, it's a reducing agent, and it's right at the bottom. Which combination of half cells will produce the highest EMF? Well, if you look here, you need one that has a strong forward reaction and one that has a strong reverse reaction. So we're going to want to mix the chlorine and the zinc. Okay, so the chlorine is Q and the zinc is P. So the answer is PQ. They are the furthest apart in the table, most likely to have a spontaneous reaction, and if you put the values in, you will see that they will give you a very, very nice positive value over 2 volts.